it's time to look at another ionizer, a pink ionizer, obviously, and one that is slightly perplexing because normally an ionizer works by applying a high voltage charge. I'll just dump that out the way, complete with instructions that are just stereotypical. It doesn't mention anything about its operation. It just basically says if it bursts into flames, unplug it, sort of thing like that. But an ionizer, typically, when you plug it in, usually has a little tuft of carbon fibers pointing out the front, or metal spikes pointing out the front, and it puts a high negative voltage on those spikes or fibers, and it puts an electrostatic charge into the air, and that results in fine dust precipitating out there. This is odd because when you plug it in, the bristles are actually pointing directly at the wall, which means it's about that far from the wall, and it is effectively going to just basically create an ionic short circuit to the wall. That could have unusual extra effects that might be quite useful. Now let me bring up the hoppy. The hoppy is still here. I just want to reassure people that because I got another one that was supposed to be the more accurate version, but they've sent me the wrong version. And since it's AliExpress, there's no chance of ever getting that sorted. Plugging it in, it says 77 milliamps, 0.6 watts. It's not even on at the moment. There's a button. This is pointless in an ionizer. You press the button, the green light gently glows up, and it theoretically starts ionizing. Let me just double check that it is ionizing. The way to find this out is to get a meter, set it to about 20 volts, stick the one of the lead to ground. Well, I'll stick it onto the soldering station here and stick the other lead in front of that little tuft, and you should see a high negative voltage, and well, it's pretty much off the scale. It's pretty good, actually. That's pretty good. You're seeing quite a high negative voltage without me even touching the fiber emitter, because it is basically creating an electrostatic charge in the air. Good results so far. Power factor is 0.034, which is terrible. That actually suggests a capacitive dropper. All the button does is off and on with it just gently pulse modulates that light, just ramps it up and switches the Ionizer module on. Enough. Let's open it. That's what you're here for. Suitable screwdriver. Screw number 1. And screw number 2. I did get it in fetching pink, just in case it is dangerous. The whole reason for the pink is just because it's quite funny when things are electrically dangerous and they're pink. It just adds an element of amusement to it. The front is fallen off with its little captive button. Here is the circuit board with a big fat capacitor, suggests the capacitive dropper, with the high voltage output right against that. I don't really fancy that much. Right, tell you what, I'm going to take a picture of this. There's a little ionizer module. Right, I'll take a picture of this and we'll reverse engineer it and see what the circuitry is like. One moment, please. And resume with exploring this very long, thin circuit board. So things worth mentioning. On the back of the circuit board are a fusible resistor, 20 ohm. We've got the dropper capacitor, which has been grossly oversized at 1 microfarad to give it a wide voltage range, so it can be used all around the world. In reality, that's putting a lot of stress on the little Zener diode here, but I'll cover that in a moment. The module is just stuck in the back. There is a little electrolytic 470 microfarad capacitor, and the connections, this case has just got the metal pins going in, and to connect onto them, they're not soldered directly. They've actually used these little connectors that are designed to go in a circuit board, and when the circuit board is put into the case, it basically slides over those pins. But instead of that, they've soldered wires on, pressed them over the pins, and then they've hot melt glued them in place. It's not a bad thing. The incoming supply goes via that resistor over to the bridge rectifier. The live goes via the capacitor in the back with its discharge resistor, and that gives the rectified output, which then simply goes across the electrolytic, couple of capacitors, and a Zener diode. W8 Zener diode rated 0.2 watts, but actually being used at 0.4 watts, which is not so great, gets quite hot. That then provides a stable 5 volt-ish supply for everything, including the little microcontroller and the module that is in the back, but actually connected with these two connections here. There's not much else to say. I shall show you the schematic for this. That's the best bet. So here's the supply coming in, there's the dropper capacitor. If you have one of these and you lived in a 200 upwards volt country, I'd recommend changing that from 1 microfarad to 470 microfarad, because that would result in much less dissipation from this little Zener diode, or Zener diode as some people prefer. Here's the 20 ohm fusible resistor. I'll draw a little line through that because it is kind of fusible as well as the resistor. There's a bridge rectifier. There's the power supply, which is just 2 ceramic capacitors, a electrolytic capacitor, and a 5.1 volt Zener diode. There's the mysterious microcontroller. It has the button input connecting to the 0 volt rail. So when you click it, it just basically pulls that pin low. It's got the little LED that does the fancy thing. It's the most fancy thing it does. It ramps that little green LED up. It's got a 470 ohm resistor in series with it, which I calculated gives about 5 milliamps through that. Then this splodgy mess here is because I thought that it was just going to be an NPN transistor, because this module only takes 20 milliamps. I've tested it. In reality, they've used a MOSFET here, just possibly what they had. They could have used a generic NPN transistor. Strange that they've used that. But it's also got a 470 ohm resistor, which also alludes to it being an ordinary NPN transistor. There is a 0 ohm link. I'm not sure why they have a 0 ohm link there. Strange. There is there. And it's going from between the positive rail and that. Maybe it was to tame it down in some way, or maybe I don't know why they used that. And then there's a 1K resistor across the module, the high voltage module, and then it's just a little spike with the negative ionization. I'm not sure what the 1K resistor is for. Is it to provide a stable load for the transistor, given this is a pulsing electronic load? Shouldn't really be needed. Or is it a little decoupling resistor across that for back EMF spikes, which I wouldn't really expect, because the first thing you're going to hit in that module is a capacitor, probably, maybe even via a diode. Very strange. Lots of little extra features. But this Zener diode gets up to about 67 degrees Celsius, which is quite hot. I mean, it's not mega hot, but it's still hot enough. The 20 ohm resistor at the input got up to 41 degrees Celsius. This resistor here, which is a fairly generous size, got up to 470, should I say, not 470 degrees Celsius, 45 degrees Celsius, which isn't negligible, it's fine. Also worth mentioning, the discharge resistor is a good high value across that capacitor, and it's a fairly big beefy one for surface mount aspect, so it's not too bad. Let's take a look at that in the flesh. Yeah, it's quite big. They've not used the tiniest they could, as many others do. So that's it. To be honest, they could have got rid of all that. They could have just got rid of that, and they could have just slapped that straight across the supply, and because you don't need to turn an ionizer on and off. You plug it in the wall and you leave it on. Now here's an interesting thing. If you have, well, I'll doodle this on another page. Turn a page over and doodle. So at the moment, and I shall zoom out for this, if you have this plugged into the wall, you would normally, if this is the wall, I'll just draw it like that, a general ground plane, even if it's plasterboard or sheetrock, it will still be relatively well grounded. So you might have a socket on the wall, and this is plugged into it. And then here is the Ionizer module. Normally, you'd either have the bristles coming out the top or usually out the front, so to put the negative charge into the air. But the fact they've actually got it just protruding out the back, creating an ionic short circuit to what is effectively a grounded surface, even if it's an insulating material, at the voltages we're talking about, the ionization, it will have that effect. I'm just going to tame this down a wee tad. But what that does pose an interesting thing here, because it does create an ionizing short circuit, you might get a slight corona discharge on these needles because of the high current flow, and that will result in trace levels of ozone. I suppose then that if this thing does warm up very slightly, it's not really going to warm up that much, but it could create an airflow past it, and that could just basically add a tiny trace of ozone into the room. It's odd. It's a strange design. It's almost like they just copied things and did what they thought was the right thing, and it's just odd. Definitely the on-off button and a microcontroller, just basically to turn this on and off and light an LED just seems odd, because really you should just unplug it from the wall when you don't need it. But an ionizer draws so little power that you can just leave it plugged in all the time. The module itself, I'll get the kink calculator for this. I measured it at about 22 milliamps, 0.022 milliamps, 0.022 amps, 22 milliamps, times the voltage it's operating at is 5 volts. The module itself only draws 0.1 of a watt. So by the time they've finished with it, the Zener diode is dissipating a lot more than the module itself, significantly more. That's very strange. But then again, this is no surprise. Strange pink things from China. But there we have it, a strange ionizer that points in the wrong direction and has an on-off button for no good reason. That is it. Quite interesting. A fairly neat design inside, but seemingly completely and utterly pointless.